Hello, I'm Dr. David Kading. Welcome to Eyecare's Lit, brought to you by Optometric Insights Media. On today's episode, we're going to be talking about how cytokines tell the dry eye story.
You're listening to Eyecare's Lit, where science meets the clinic. Hosted by Dr. David Kading, we break down the latest research, clinical studies, and real-world insights, turning complex data into practical care for today's eye doctors, from dry eye breakthroughs to myopia management and beyond. This is Eyecare's Lit, brought to you by Optometric Insights Media.
But before we get into the data, I want to stop and thank Beatrice for their support of this podcast series through a non-restricted educational grant. The tears carry a message about how our eyes are coping with stress and inflammation and repair. These messages come from something called cytokines, which are tiny immune signals that are released by surface cells of the eye and the immune system itself. Cytokines are the body's instant messaging system. They send alerts between cells like send help or stand down or repairs in progress. But in healthy eyes, those signals kind of stay balanced. But in dry eye, the alarm side of that conversation takes over. Inflammatory messages keep circulating while calming ones kind of fade away, leading surface cells to become overreactive and overreact. The result is a familiar vicious cycle that we talk about, the tear instability leading to irritation, leading to tissue damage, back to instability, this lack of homeostasis. Today, I want to review 4 studies that talk about cytokines. I've left their description and their references in the description below. The first one is tear cytokine level in Sika syndrome-related dry eye, which is a 2023 study. Dry eye disease and tear cytokine levels, which is a meta-analysis, and this one's from 2020. Association of tear cytokine ratios with symptoms and signs of dry eye disease, which is a 2024 study. And the latent profile analysis, tear cytokines and their association with severity of dry eye disease in the DREAM study, which was published last year, 2024. So 2 of these studies are large reviews that talk about the chemistry across dozens of different studies. The first looked broadly at dry eye and found that inflammatory messengers kind of dominate here. The second focused on autoimmune related or Sika dry eye, showing the imbalance is even stronger, more alarm signals and fewer regulatories. So the key point kind of here is that dry eye isn't just about, moisture in the tear film. It's this immune conversation that has gone wrong. The suppression isn't what it should be. The overact action is even more than it should be. And in autoimmune cases, that argument grows even louder because the tear glands themselves become, inflamed participants in all of this. As my mentor describes it, it's a localized autoimmune disease is what we have with dry eye. And this group of studies certainly points to that for me. So measuring one signal at a time kind of only tells us half the story. The really insight comes from the balance, how much go there is versus the slowing of the tears and what they contain. In one of the studies that we reviewed, the Dry Eye Assessment and Management, or DREAM study, the researchers compared these balances with clinical results and found modest but consistent links in dry eye patients. Eyes with stronger inflammatory tones showed more surface damage and less tear stability, even when the symptoms didn't always match. And I think that's really the key for us as clinicians, is that symptoms and signs don't always match, and we may see something that doesn't tie in with what our patients are feeling or vice versa. These findings kind of remind us that measurable inflammation doesn't always equal discomfort, but it does shape the disease and how it behaves for our patients. And then a follow-up analysis from the same project grouped patients by their overall tear chemistry patterns. Two main biochemical fingerprints of inflammation emerge. One showing a strong unrelenting immune system, and these eyes looked worse clinically. The other showing a more balanced mix of signals. And these were noted as milder under the slit lamps, but sometimes the symptoms were the patients were just as uncomfortable. These molecular voices explain the symptom sign mismatch clinicians are seeing every day. Like I said, not all dry eye acts the same because the chemistry underneath it isn't the same. But across all four studies, the message kind of is clear here. Dry eye is an immune balance disorder, and as tear testing tools improve, we're going to be able to assess the cytokine panels even more hopefully clinically. We hoped that we could have seen some even by now. I was hopeful that we would have some tear analysis where we could look more intricately at these cytokines. But what we've discovered is it's really complicated, and particularly for clinicians, optometrists, and ophthalmologists who have, a clinic, having that type of tier assessment at the level that we need to have it has a lot of burdens around regulatory. So as tier testing, improve cytokine panels could help us as clinicians. Specifically, what I'm hoping is distinguish autoimmune from more of the evaporative forms. We have some really good signals for that now, but we could test the samples even better. They could match anti-inflammatory therapy to each patient's profile. And the other thing is track whether treatment restores the balance or is it just simply relieving the symptoms. And that's where I think it would be really helpful for us. But for now, methods vary and cutoffs aren't standardized for us. But the pattern is unmistakable. When inflammation outweighs the regulation, the eye struggles to heal. And that's when these patients tend to go into this autoimmune almost type of disease that they're seeing. Cytokines aren't villains, they're storytellers of inflammation, and learning to interpret the tone could make dry eye more personal for our patients. And if we can test it, more precise and then far more effective. So grateful for these studies that are digging into that and kind of showing how it works out. Hopefully, as clinicians, we'll be able to dig into that a little bit more in the future and have a better understanding. But for now, thank you for joining me for this episode of Eyecare's Lit. And again, thank you to Beatrice for their non-restricted educational grant. I'm David Kading for Optometric Insights Media.